Now, what do we use law of sines for? So far we have been dealing with right triangles. So we can solve any right triangle using a Pythagorean theorem and basic trig functions, as long as it's a right triangle. But what happens if you don't have a right triangle? How do you solve for the angles, and how do you solve for the sides? Well, this is what it does. Law of sines and law of cosines let us do that. So before we get started on what law of sines is, okay, let me state what the law of sines says. It says sine of angle A is to side A, and that is proportional to sine of angle B is to side B, and which is proportional to sine of angle C is to side C in a random triangle, okay, where you know A, B, and C. Okay, non-right triangle. That's what we're going to work with. Now, before we get going and applying this law of sines, law of cosines, since this is so easy to prove, I'll prove it. Okay, so let's, it's not that long. So let's just make a random, let's say, non-right triangle. We'll call that A, B, and C. Okay, so let's drop a perpendicular. Okay, and we know this is side H. Okay, in a triangle, this is my height of this triangle. So we also know that the altitude of the height is always perpendicular to the base. And of course, let's put the sides in. That's side A, that's side C, and that's side B. Okay, we know that just by basic trig, if this is my angle, sine is opposite over hypotenuse. So sine of angle A is equal to opposite, which is H, over hypotenuse, which is C. Okay, since this is a right triangle right here. Okay, we also know that if you look at that angle, that sine of angle C is opposite, which is also the same height, over hypotenuse. But so in this triangle here, the hypotenuse is the A. So if you solve for H in both of these, you're going to multiply by C, so H is equal to C times sine of angle A. And then when you solve for H in this one, you're going to get H is equal to A times sine of C. Since this H is the same H right there, we can set these two things equal to each other. So you have a C times sine of angle A is equal to A times sine of angle C. And then when you divide both sides by A, they cancel. I get that. And then when you divide both sides by C, okay, they cancel. And then what I have left now is sine of angle A is to side A, and sine of angle C is to side C, and there it is. And we can do the same thing for angle B. So that's the law of sines. You have to memorize that. Okay, so we're done with law of sines. So let's do a couple of problems. Okay, applying law of sines. Let's start with section 39. Okay, section 39, problem number 2. And they tell you that angle A is 70 degrees. So we'll use big capital letters for angle. So that's 70 degrees. And they tell you angle B, okay, is 60 degrees. And they tell us side C is equal to 4. Okay? So okay, so let's go ahead and draw our little triangle. We'll call this Angle A, angle B, angle C. It's not a right triangle. Let's put in the angles we know, and that happens to be 70 degrees, and this happens to be 60 degrees, and we know side C, that is 4. And all we have left is to find out what this angle is, and we can do that by adding 60 plus 70, which is going to give us 130. And we're going to take that and we're going to subtract that from 180, because all three angles of a triangle have to add up to 180, so that is going to give us a 50 degrees. So that is 50 degrees. Okay, so we found all the angles. Now we have to find the sides, remaining sides. So we can use law of sines to do that. And we can go sine of angle A is to side A. Okay, is equal to sine of angle B is to side B, and sine of angle C is to side C. Okay, in order for you to use law of sines, you have to know an angle and a side across from it. So we know that side and we know that angle. We didn't know initially, but we know that now. So we're going to use that. So we're going to say sine of 50 degrees, which is the same thing as like we're using that sine of C, is to side C, which is 4. That's equal to, now it doesn't matter which one we want to find, so let's find angle A. So sine of 70 degrees is to side A. So what we're going to do is make sure your calculator is in degrees. So we're going to find sine of 50 degrees. So sine of 50 degrees. Okay, and then we're going to divide that by 4. Okay, divide that by 4 and find the answer. And then what we have here is 0.1915 is equal to sine of 70 degrees is to A. Okay, so let's go find sine of 70 degrees. So I'm going to find sine of 70 degrees, and that turns out to be so the right side is 0.9397 over A. Okay, so all I'm going to do now is, this is really over 1, so I can just cross multiply here. Okay, and then divide everything by 0.1915. So my A will turn out to be 0.9397, and since this is next to A, I got to divide by that. So I'm going to divide that by 0.1915 to get the A. So now we're just going to divide what we had initially by 0.1915. Okay, and that turns out to be A is approximately, okay, we'll round all the degrees to a whole number, and we'll round each side to 1 decimal place, so 4.9. So side A is 4.9. Okay, so the only thing that's left is to find out what side B is. Side A, and we already know what side C is, so let's go find side B. Okay, let's go find that. So since we already know this, which is sine of C or sine of C over C, we can use that. Okay, and let's go ahead and use that, and that is sine of 50 degrees is to 4 is equal to, we're finding side B, so it'll be sine of 60 degrees is to B. Okay, so what did I find for sine of 50? So let me scroll up with my handy dandy calculator. Okay, sine of 70 divided by 4. That turned out to be sine of 50 divided by 4, and that turned out to be 0.1915 is equal to sine of 60 degrees. So let's go find sine. So, okay, sine of 60 degrees. Okay, enter. And that turns out to be 0.8660. over A. So I'm going to cross multiply over B. Okay, I am going to cross multiply. So this is my B. Okay, let me erase that. Now when I cross multiply this, okay, my B will equal to 0.8660 over 0.1915. So we're going to divide that by 0.1915. Okay, which is going to be approximately 4.5. So we're going to write this as 4.5. We're done. We found all the angles, we found all the sides. Okay, so let's take what's known as an ambiguous case. And let me explain to you what an ambiguous case is. So let me clear this out. Okay, in an ambiguous case, let's do number 12. Okay. So let's say you have a triangle like that. Okay, and this is, let's call this angle C, and let's call this the angle A, and call that angle B, and they're giving us 25 degrees for the C, and then they tell us side C is 1, and they tell us side A is 2. Okay, so we have an angle, and then we have a side opposite of that, which is 1. Okay, that means we can use this law of sine. So when can you use law of sines? When you have an angle, side across from that. But you got to be careful, okay? But sometimes you have two triangles. So let's just solve for this one at first, okay? And then let me show you if it's possible to have two triangles. All right, so we're going to use sine of A is to A is equal to sine of B is to B, and then that's equal to sine of C is to C. Okay, so we know this right now, which is sine of 25 degrees is to 1 is equal to, we know side A, so that'll be sine of angle A is to side A. Alright, let's go find sine of 25 degrees. So sine of 25, okay, and that is 0.4226. Okay, since that's divided by 1, that's all I'm going to have. And then I have sine of angle A is 2. Now I know side A, so which is 2. So I have sine of angle A is to 2. Okay, so I'm going to multiply that by 2. So I'm solving for angle A. So I'm going to go times 2. And so what I have here is 0.8452 is equal to sine of angle A. Of course, to get rid of that, we have to take inverse of that. So let's go take sine inverse. Sine inverse of 0.8452. Okay, and we hit enter, and that will give us for an angle A. So angle A is sine inverse of 0.8452, and that turns out to be 58 degrees. Okay, so this angle is 58 degrees. Now we need to find side B and angle B. Well, angle B that's not hard to find because we know that three angles have to turn out to be 180 degrees. So we're going to add 58 plus 25. Okay, that's 83. So we're going to take 180, and then we're going to subtract 83 degrees, and the remaining is going to be my angle B. So this is now turns out to be 97 degrees. Okay. Now we can find side B. So this side B, we can find that by going, since we already have this, we can go ahead and use that. So sine of 25 degrees is to 1 is equal to sine of 97 degrees is to side B. Okay, so this is 0.4226 is equal to sine of 97 degrees. So let's go find that. Sine of 97 degrees. Okay, hit enter, which turns out to be 0.9925 over b. So of course my b is going to be 0.9925 divided by 0.4226, and enter, and that turns out to be 2.3. Okay, so I found that to be 2.3. Okay, so we're happy we found all the sides, but that's not the case. Sometimes you have what's known as ambiguous case, and you always have to check for ambiguous case every time you use law of sines. Okay, here we go. So what you're really saying is, we have that, and that is given to us, that's 25 degrees. Okay, that's the angle C. We have that, this side, which is 2, and that hasn't changed. And this side here is 1, and that's the side C. Now what if I take this side, the dotted side that I have, which is 1, and I slide to the left? And now this is an isosceles triangle. That means these two sides are the same. Okay? So what does that mean if those two sides are the same? Let me draw a little better. Okay? So we know that happens to be 58 degrees. So that means that's 58 degrees also, because that's what isosceles triangles do. So this part is an isosceles triangle. Okay, if that's 58 degrees, then this angle right there next to that, which is supplementary, so it would be 180 minus 58 degrees. So that turns out to be 122 degrees. So that's 122 degrees. Okay, so now look at this little triangle. That's my angle B up on the top, but that's angle A. So look at the little triangle that I have here. Okay, in that little triangle, okay, I have a 25 degrees, 122 degrees. So when I add 122 plus 25, okay, I have less than 180 degrees. I have 147. So when I subtract 180 minus 147, okay, what's left is 33 degrees. So I could have a second triangle, and that angle is 33 degrees. Now, if these two angles add up to more than 180, if 122 and let's say and then plus 25, this is less than 180. Okay, but if these two angles ever add up to more than 180, then you only have a one triangle. Okay, all right, and sometimes you don't have any triangles because this, when you try to solve this, you'll get error message in your calculator. So right now we have two triangles. So we have a smaller triangle. I have to find that. I already know angle C. I know angle B. And I know angle A, 122 degrees. So the only thing that's left is to find, and I also know side C. And that's 1. The same side as that side right there. So the only thing that's left to find is that little small side called side B. And again, we can use the same thing we have found before. So we can go sine of 25 degrees is to 1 is equal to sine of now 33 degrees. 33 degrees is the side B. Okay, we already found out what the left hand side is. That's 0.4276. Okay, is equal to sine of 33 degrees. So let's go find that. So sine of 33 degrees, and that's 0.5446 over b. Of course, we're going to cross multiply that. Let me erase that a little bit. Okay, it looks like 1. It's a decimal point. Alright, so now we're going to cross multiply and solve for b. So my b is equal to 0.5446. Divide that by 0.4276. So we're going to divide that by 0.4276. Okay, and we're going to enter, and that turns out to be, side B now turns out to be 1.3. So we do have another side, and that side here turns out to be 1.3. Okay. So I'm going to list everything that I have right now, so that way that you know we have two triangles. So let me erase this real quick here. Alright, so what do I have is I have on one triangle, okay, alright, so on one triangle, angle A is 58 degrees, okay, side A is 2, angle B is 97 degrees, and side B is 2.3. And then I have angle C is just 25 degrees, and then side C is 1. Okay, on the second triangle, have angle A, okay, is 122 degrees, and then side A is still 2, that didn't change, and then I have angle B is 33 degrees, and then I have side B, which turned out to be 1.3, and then I still have angle C, which was given to me, and that is 25 degrees, and then side C, which was also given to me, which was 1. So these are the two triangles I end up having sometimes when I